Okay. So if I were to say to you, here are the three things that we're going to do. We're going to graph a line. And there are a lot of different ways to do it. Okay? So the first thing we're going to talk about is make a table of values. And here's the good news. It doesn't matter what form I give you the equation in. I could give it to you in y equals 3x minus 1, 2x plus 3y equals 8, all different kinds of ways. If you know how to use a table of values, then you can get the line on the graph. So I have a big blank graph here, and I want you to graph it. So here's how this works. A table of values is kind of your fallback. You know what your fallback means? It means if you forget all the other ways, you can always graph by making a table of values. So let's take this table right here, or this equation, and let's make our table of values. And basically what that means is it's like a T-chart. And guess what? We did this in Unit 3 with functions, and I said, hey, here's your domain. What's your range? We did this before. So here, that's the good news. Do you remember me saying, hey, like when you go to the airport and you input an X value, let's say we choose an X value, that's 3. And inside this equation, or this little X-ray machine, I put 3 in for X, I multiply by 3, I subtract 1, and then what comes out? The Y value. So do you remember me telling you that the X is called the input and the Y is called the output? We also know that X is the domain and Y is the range, right? All right. So if I were to ask you to take a look at that and then fill in some values. So this time the domain is not being given to us. It doesn't say, hey, make sure your domain is greater than 5. That was Unit 3. We're done with that. So what they say to you is, in a table of values, you pick whatever X values you want. And there are some that are going to be easier to choose than others. So let's stop and think about what our X values mean. It means whatever I choose for X, I got to put right there. And what does 3X mean? What operation? Multiplication. So whatever I choose for X, I have to multiply it by 3. 3 is a whole number. I can put any value I want in because I can multiply anything I want by 3. Okay? So here's going to be what my suggested domain is for you. -1, 0, +1 for right now. Here's the reason why. Having 0 as your X is always helpful because it's going to give you your Y-intercept. Calculation with 0 is always easy. I'll show you in a minute. And then it's good to have a negative value and a positive value just because it gives you a good sampling of the whole graph. Do you remember me doing that before? Do you remember me putting 3 in? And so now I have to do some calculations. I'm going to show it to you written out, and then you're going to go, Ms. Z, I could do that in my head. And I'm going to say, okay, then go ahead. But I need to at least show you what we mean by this input-output. So if I chose my X value as -1, the first thing I'm going to do is make it -1 and figure out what the Y would be that goes with it. So then I just have a little bit of calculation to do. This is -3. -3 minus 1 is -4. So when I made my X -1, my Y was -4. Yep. This is called making a table of values, and it should look very familiar. So now I got to do that with my next X value, which I chose 0. Here's why I always choose 0, because it's really, really easy. And when X is 0, it's basically like nothing, because 0 kind of makes that disappear, because 0 product property, and 0 minus 1 is -1. Okay? Hey, I knew that, because I can tell when X is 0, it's going to be that number there. And I got one more value to do this for. This time I'm going to make X +1. Man, this is a lot of work, which guess what? This is why you don't have to do it all the time. You are in advanced algebra. This is +1. You should be able to do some simple calculations in your head, and I will not make you show this. This is just teaching purposes right now. And so a Y value that comes out when X is 1 is that Y is 2. Okay, you with me? So if the purpose of this lesson in 4.2 is graph the line, graph the line, graph the line. I know some of you know a shortcut. We got to kind of take a step back, and I need to make sure you can make a table of values. So guess what? Table of values comes from x's and y's. Well, there's my ordered pairs. When x was -1, y was -4. When x was 0, I calculated y to be -1. And when x was 1, y is 2. You have everything you need. Plot your points, and you are done. So basically, here's my graph. You want to know what's funny? Kids can do all this work, and then they end up plotting the points wrong, which is like a third grade skill, right? We learn in 4th grade how to plot ordered pairs. Your house is at this point. What is the coordinate of this point, right? So -1 means go to the left, and -4 means go down. 0, oh, those are the hardest ones, right? You're always like, is it on this one or this one? 0 means don't move left or right, but go 1 down. And +1, +2, here's how you know you're going to be right. If you put down a ruler or a straight edge and they're all on a straight line, and obviously mine's human error here, if they're all on a straight line, then you know you did it right. If you got 2 over here and 1 over here, one of your calculations is off, go back and check it. Okay? Don't ever leave it not straight on a test. Okay? So that is how you would figure out making a table of values. So now I want you to take a look at the tables that I gave you, the graphs that I gave you rather. And I want you to go through number 2 with me. So let's just make a table here. Let's take a look at number 2. So I'm looking at my coefficient for x. I see that it's an integer. Every integer is easy to multiply any number by. I'm just going to do -101. These calculations, let's try in our head. If I make x -1, then that's -1 times -6, which is +6. And +6 plus 3 is going to give you what? Find those numbers. 9. Let's do it again. 0, super easy. Because 0 times anything is 0, which is kind of like it not even being there. And 0 plus 3 is 3. There's my y-intercept. Let's get used to that now. -6 times +1 is -6 plus 3 is -3. If you followed me on that, awesome. If you didn't and you are a visual and you kind of need to write a couple things down, then go for it. I have everything I need to graph this line. Sometimes I go off the graph because of the points I choose. -1, +9 is all the way up here, probably by the 3. 0 means don't go left or right, just go 3 up. And then 1, -3, and then you'll use your ruler or your straight edge, and you'll make sure that they line up, which they do. And I asked you to graph this line. So guess what's cool about doing this? Yeah.
I use 0, 1, and 2.
Yeah, and that's okay too. 0, 1, and 2 is good. I just like to have a sampling of like negatives and some positives. Yeah. And if you did that, your other point would just be somewhere down here, right? Okay. So here's a really cool thing about this. What do I know from 4-1? Do I know how to find the slope of a line? Yes. Is this line in slope-intercept form? Yes. What's the slope of this line? -6. Can I check to make sure it's -6 and make sure my points are right? From here to here, did I go down 6 and over 1? Yep. So you can use what you learned in 4-1 to make sure your 4-2 work is done correctly. Following me? All right, let's hop on over to number 3 because this is an easy one. As soon as you see this one, you say to yourself, awesome, this saves me a little bit of work. I don't have to do a whole bunch of calculation, but Mrs. Z still wants to see the table associated with this, and she still wants me to graph it. So what this means is this time you don't get to, well, you do get to pick your x's, but this time your y's don't depend on anything. Your y's have got to be a -5. And you can pick whatever you want. You can still use -1, 0, 1. And when I go to plot this, -1, -5, 0, -5, and +1, -5, that's the line that I expected. It has a slope of 0, and it's a horizontal line going through the y-axis, right? So follow me now to number 6. How could you make a table to match number 6? These are kind of little bonus problems when you see them because you know it doesn't require a whole bunch of work. This time it's telling you, hey, make sure all your x coordinates are 5 And I don't care what you make your y coordinates. Make them 1, 2, 3 if you want, because it's still going to graph the same. Positive 5, negative 1. Positive 5, 0. Positive 5, positive 1. Connect it. There's your straight line. And this confirms for me that a x equals line is vertical and has a slope that is what? Undefined. Okay, you with me? Because it's time to kick it up a notch here. So let's take a look at number 5. Scooch on over to number 5. And right away I know that you notice it. It's there. It's a fraction. And when people see fractions, they lose their mind. They start freaking out and they start, I don't know what to do because it's a fraction. Okay? Well, guess what? It changes one little thing. That's all it changes. So watch. Before I go in and write my negative 101, stop for a minute, because whatever I put in that spot right there, I'm going to have to do what with it? Multiply it by a fourth. So, just a quick thing here. If I choose negative 101, I'm going to have a fourth. And then I'm going to have to add a fourth to a half, and or to 2. And I know you can do it, but why mess with it? So, Haley has an idea. Yes. So, what she's saying is, well, because my denominator is 4, I want to choose x values that are multiples of 4. Because when I put it in, the x, the 4s are going to cancel. So you know what I'm going to do instead of negative 101? Negative 404. So negative 40, positive 4. Could you choose 0, 4, and 8? Sure. Okay, this is the hardest part that the other hour dealt with. Watch. This is probably not an in-your-head one like all these other ones were. So let's take a look at what this work would look like. This work is going to look like, okay, y equals 1/4 times x plus 2. Well, the x value that I'm choosing first is negative 4. But watch how I write it. I'm writing it this way on purpose. I'm writing it as negative 4 over 1. Because if I just wrote it like this, 1/4 times 4, a lot of people don't see the cross cancel happen. Now when you see it as a numerator here and a denominator there, they cross cancel. So listen up, what you want to do next. Don't worry about the negative. Just say to yourself, hey, what is a positive number times a negative number? It's a negative. So then you're done worrying about the negative. And now what happens with the 4s? They cancel. And what's 1 over 1 times 1 over 1? 1. And what's a positive times negative? Negative. Oh, so that just works out. Here's another way to look at it. What does taking 1/4 of something mean? Dividing it by 4, right? So split negative 4 into 4 equal piles, and you get negative 1. Now add 2 to it, and you get 1. That was it. Here's why I like 0, because 0 times anything, especially fractions, make it disappear. That fraction is gone. And what's 0 plus 2? 2. I knew that because that's my y-intercept. I know it's going to go right here. Okay? And then now, here's the other thing. Let's go back and make 4 positive this time. Don't do a whole extra bit of work. I mean, you could rewrite it again, and you could say 1/4 of positive 4 plus 2. All it means is that it's this time, instead of negative 1, it's going to be positive 1. Because what's 1/4 of 4? 1. And what's 1 plus 2? 3. Now I have my 3 ordered pairs. All I have to do is plot them to make sure that they line up. And if they do, we're good. Negative 4, positive 1. 0, 2 is always on the y-axis. And then 4, 3 goes here. Looking good. And then let's use what we learned in 4, 1 to make sure we got our slope right. What's the slope of this line? 1/4. Well, let's check and make sure it's 1/4. Is it up 1 over 4? Yep, up 1 over 4. We're good. Okay? We're going to do one more. Let's take a look at number 5. Actually, let's do number 1. All right. So I see a fraction, except I don't see 1/4. I see 7 halves, which makes it a little bit trickier, but not completely. So what values do I want to choose for my domain if I have to plug it in right here, multiply it by 7 halves? That's ugly. Yes, I want to use my denominator, a positive and a negative version of it. So let's choose negative 2, 0, positive 2. So for example then in number 4, what would I want to make my x values? Negative 5, 0, and positive 5, okay? There are people who don't think to do this, and they use negative 1, 0, 1, and then they multiply 1 times 6/5, and they get 6/5, and then they have to sometimes subtract 1, and they walk up to my desk and go, oh my gosh, I hate fractions. And then I said, well, then why did you use 1, 0, negative 1? What do you mean? Just use 5 and cancel it. They're like, oh. So whatever your denominator is, and Brianna, if you'll shut that door, please. So watch. This creates a little bit of extra work. So I'm going to take, 7/2, multiply it by negative 2 over 1, and then subtract 2 from it. So guess what? Last time when I did that, the 4's canceled, and I just had 1. But this time when the 2's cancel, I don't have a 1, I have what? 7. And what's a positive times a negative? So what is, ready? 7/2 times negative 2. It's negative 7. You see why? Because positive times negative is negative, and when the 2's cancel, I'm left with 7 over 1, which is 7. That's going to be the hardest part of 4-1 or 4-2 part 1, is figuring out the fractions. And so now what's negative 7 plus negative 2? Negative 9. Okay? 0, awesome. I really don't even need to calculate it. What's 0 times anything? And 0 minus 2 is? That's my y-intercept, which means I know it's going to touch the y-axis right there. And I got one more to do. Let's go back up and use this problem. I already know what 7/2 times negative 2 is. What's 7/2 times positive 2? What's positive times positive? Not negative 7, but positive 7. And now what's 7 minus 2? 5. All I have to do is plot these 2 points, make sure it lines up, and then we have made a table of values. Goes a little bit off the graph, negative 2, negative 9, positive 2, positive 5. Looking good if we connect it. Let's use our knowledge from 4-1 to check it. What's the slope of this line? Rise 7, run 2. Is that good? 1, 2, 3, 4, 5, 6, 7. Run 2. We're good. Okay? All right. So now, it's not that easy because flip that over. Flip that over and look at number 1. Right away, what do you notice? The equation is not in what? Slope-intercept form. And man, is it easy when it's in slope-intercept form. So guess what? When it's not in slope-intercept form, what do you think you have to do? You got to put it in slope-intercept form. So remember what we learned in 4-1, how to solve for y? So first thing I want you to do is put in slope-intercept form, which basically is a fancy way of saying solve for y. And here's what's so cool. You already learned it, right? So you know this was number 3 on the test I just passed back to you 20 minutes ago. If you got number 3 right, then you're good. Get y by itself. Cancel out. Please don't skip this step. A lot of you are skipping that, and you're getting your sign wrong on the other side. So this then becomes a brand new equation, negative 7x plus 5. And now that it's how I want it, then you make your table of values. We're not going to go through and do the calculations, but I do just kind of want to show you, do I have to choose negative 7, 0, and 7 here? No. It's an integer. I can choose negative 1, 0, positive 1, and multiply it by 7 and not have an issue. It's only when your x coefficient is a fraction. So negative 1, 0, and 1, calculate, graph. Moving on, look at number 2. Let's solve this one for y, which usually means you have to cancel out the x term first. Let's kind of move up here so we have some room and aren't crowded. That leaves me with 5y. Be careful if that 5y had a minus in front of it. You'd have to bring that. Then I have negative 3x minus 5. And then the last step to get y by itself is divide everything. This is a very useful tool, solving for y. You're going to need it in all of Unit 4 and all of Unit 5. So learn it now. And so y is equal to negative 3/5, because you can't, and you can just put the x in the middle. And what is my y-intercept? Hey, remember last time how I kept saying, that number at the end doesn't matter because all I want is slope? Does it matter now? Yeah, because if I don't calculate it right, then I calculate my points wrong. So what is a negative 5 divided by a positive 5? So I'm going to do a minus 1 at the end, right? Well, we won't do the calculations to save on some time, but what are you going to choose for your x values? Unless you love working with fractions, I would choose negative 5, 0, positive 5. Choose whatever your denominator is. Make it easier on yourself. Let's do one more. Let's just do number 4. So to solve for y, get x out of there. And that's going to give me 5y is equal to negative 6x plus 20. And then divide by positive 5, just like we did up top. Same deal. This time y is equal to, what is my slope? Negative 6/5. And if I could reduce it, like say that was a 10. If this was a 10, what would I make my slope? I would make it negative 2. Because negative 10 divided by 5 is negative 2, right? So always just reduce as much as you can. What's my y-intercept here? What's 20 divided by 5? Positive 4. Don't forget your x. What are you going to choose as your x values? Same thing, right? Negative 5, 0, positive 5. Substitute it in. Okay? Let's do one more calculation like this and we'll be done, because I did find that was the most confusing part. So let's take negative 6/5 and multiply it, don't forget about that plus 4, by my first domain that I chose, which is negative 5. First thing I ask myself is, what's a negative times a negative? Positive. Then I'm done. I don't worry about the negative sign anymore because I've already taken care of it. And the 5s cancel. And what's 6 over 1? Positive 6. And what's 6 plus 4? 10. And then you go from there. Okay? So that's how you're going to do part